All right, so we are going to talk a little bit about data, and specifically we're going to talk about the types of equipment that you might see in a chemistry laboratory. Before we do that, though, I want to refresh our memory. We did talk about this very briefly on the first day of school, but I'm going to talk about it again today. So these are the learning targets and how they're coded, so I want to take a minute or two to talk about that. First of all, if there is a U in front of a learning target, like in the case of U 1.1e, that U is what we consider a universal learning target. That learning target is something that every student in this class should know. If there is an E at the end of a learning target sequence, so U 1.1e, we call that an enduring learning target. That is a learning target that will show up on the semester exam. Okay. If there is an H instead of a U, so if it's H 1.11, which is one of our honors learning targets, that is an honors learning target that everyone will be exposed to and everyone should try to assess. And then if you get a 3 or 4 out of on the honors learning target assessment, on all of the honors assessments, you can earn the honors designation on your transcript. And then lastly, the L means it's a lab skill or lab content, and that falls under the universal sort of also, so it's everybody should know that. Questions about that again? Okay. So when we go back into lab, we collect data a couple of different ways. One of the ways we collect data when we're back in lab is we simply make visual observations. Other times when we collect data in lab, we actually have to measure stuff. So the different types of equipment that's going to be available to you will allow us to help you measure things or collect data that you need. And as I talk about these, some of these pieces of equipment are going to be more accurate than others, and we'll talk about why in a little bit. And so when I design a lab experiment, or at some point when you write your very, very own procedure, you might have to choose the correct piece of glassware to use for your materials list, and that's going to be based on your understanding of what glassware does what. So you do have this in your notes. This is the part that I didn't screw up. So you have a picture that looks a little something like this in your notes, and that picture right there is going to help start to identify a couple of these pieces. So these 4 pieces of glassware are used to hold things in the lab, or we can do a chemical reaction inside of them. We can put a solid inside of them. We can put a liquid inside of them. I guess we could put a gas inside of them, although it's not necessarily something that we do often. They also tend to not be very accurate in terms of measuring. So the first piece of glassware that we use to store things or hold things is a beaker. Okay? A beaker looks like this. The beaker does have increments on it, that it does have marks, so it's like 100, 200, 300, 400, 500, and it will hold roughly 600 milliliters of fluid. The issue with this is it's not very accurate. And I know it's not very accurate because when I take this particular piece of glassware and I fill it up to like the 200 mark, it's about 200 milliliters of water. It's not exactly 200 milliliters of water, it's just about. So if you're ever in a lab and I say to you, get about 250 milliliters of water, you just might grab a beaker and fill it up to about 250 and call it a day. If I say get exactly 250 milliliters of water, that's a whole different other story, okay? So this piece of glassware, again, is called the beaker. The next piece of glassware that we need to be responsible for understanding and where to put it is the test tube. What do you call it? Is the test tube. So here is a test tube. You guys have all seen these before. Again, these are good for storing things, holding things, doing small amounts of chemical reactions in, but they also are not very accurate. So here's your test tube. The other 2 pieces of glassware that are great for holding things are my 2 favorite pieces of glassware of all time. They are the Florence flask, which is this one, which is curvy and round-bottomed-ish, and then they are the Erlenmeyer flask, which is triangular shaped, and it looks something like this. Both of them, they have an amount on them, 250 milliliters, but neither of them are very good at measuring. So they're great for storing things. As a matter of fact, they're great for transferring things. They're great for potentially doing a reaction in, but they're not great for measuring exact amounts. Questions? All right. The equipment that we definitely use to measure things are, starting off, the graduated cylinder. And how I know the graduated cylinder is a much better measuring device than, say, the beaker is that this has more increments or marks on it. This has more increments or marks on it. The more lines or increments or marks, the more accurate you can get to. So if I say I wanted, say, 25 milliliters of water, I might use this and might be able to get close to exactly 25 milliliters of water because of the incrementation, the number of marks. So these are good to measure. Another thing that we use to measure is something called a balance. This is a triple beam balance. You may have never used one of these before, and that's fine. You will not use them in this class either. But when I say go find the mass of something, and then you'll be like, oh, okay, and I'll be like, where did you get that number? And you'll be like, the scale. You'll be like, the scale, this thing. And I'll be like, the balance. And you'll be like, the scale. And I'll be like, the balance. And you'll be like, the scale. And then we'll have a little argument about what these things are. These are balances. Scales are things that you have at home. So let me try to illustrate the difference. This is a triple beam balance. If I take my keys and I put my keys on here, and I try to get this as level as possible, which it's not, but it's pretty close, okay? What the masses on this side of the balance are doing are basically canceling out gravity. So they're canceling out gravity, and so that we're trying to get the actual mass or the amount of matter that's present here, okay? The electronic balance does the same thing, except it has a little math program that's coded into it that simply subtracts out or negates the amount of gravity that's on the pan. When you're at home and you stand on the scale doesn't do that. It simply just takes the mass of you and the gravity pulling down on it, and so that's the subtle difference. Kind of not super important, but it is important in some ways. The last accurate piece or measuring device that we're going to be talking about today is something called the burette. Okay, the burette is another device that allows us to accurately add liquid, like an acid or a base, to, say, I don't know, an inaccurate device like an Erlenmeyer flask. Okay. It has a valve on it, and when you have the valve this way, nothing comes out of it. And when you have the valve this way, liquid comes out of it. Okay? And the incrementation or the marks on here are good to like the 100th place, which means it's significantly more accurate. So we have things that we store stuff in, we have things that we measure stuff in, and then lastly, we have other pieces of equipment that you might be familiar with, and this slide you don't have. So just pay attention. I'm going to leave it up there. Okay. The first thing on this slide is the deionized water bottle. It is a very, very specific bottle that only has a very, very specific type of water in it that is as close to just pure H's and O's as possible. When we put water in here, it's water that has been run through a very specific filter that removes ions and debris to a very specific amount. So this is as close to pure water as we can possibly get it. With that in mind, the water in here does not come out of the tap water or the sink water because that has been contaminated by, like, I don't know, the city putting in chlorine and fluorine. And contaminated is like is a bad word, but it really isn't, because this is pure And even if something's been added, technically that's contaminated, even though it's good for you. So we never put tap water in here. If you do run out of water, ask me and I'll fill it with deionized water that we make when we run it through a filter in the office or in the lab prep area over between 27 and 21. Another piece of equipment that you'll find at your lab drawer is a Bunsen burner. Bunsen burner has a rubber hose on it, and that allows gas to travel through it. And when we use this for the very, very first time, I will refresh your memory how to light a Bunsen burner and adjust it properly. But for now, you just need to be aware that they exist. Another piece of glassware that you will find in your lab drawer is something called a glass stirring rod. It is glass, and it is glass on purpose. Glass tends to be something that we refer to as inert. Inert is something that doesn't react. So if I take two chemicals and I mix them together and I want to make sure that they are equally distributed and I start stirring them with a glass stirring rod, the glass stirring rod won't react with the chemicals themselves. So glass stirring rod. Then we have wire gauze. And back in the day, wire gauze used to be exactly what it looks like, wire with this white stuff in here, and this white stuff used to be asbestos. It's no longer, it's not safe. Now it's some type of porcelain material that they wedge in there. But what they do is when you're heating something, the Bunsen burner flame will come up, and if we don't have the wire gauze here, the source of heat will be right here. And it won't heat very evenly, it'll just be here. What this does is when the Bunsen burner flame hits it, it spreads the flame out so that it's more even in terms of heating the surface. So that's what wire gauze does. This is a funnel stuff. I don't know what else to say about that. This is filter paper. Actually, filter paper goes into a funnel. So if I take circle and I make it into a taco and I make it into a slice of pizza and then I open it up just right, I get an ice cream cone. And if I take that ice cream cone and stick it into my filter, I can now filter out stuff, or into my funnel, I can now filter out stuff and collect something on the bottom. This filter paper is no different than a paper coffee filter that you might have at your house, okay? But it is subtly different in the fact that the fibers in here are significantly tighter meshed together or woven together, so it lets through really, really tiny particles, whereas your coffee filter will let through bigger particles. And different types of filter paper have different, will allow things through at different rates. So this one, the stuff that we're going to use is pretty tightly woven, so it'll only let through stuff that's completely dissolved and not stuff that's solid. The next thing we need to talk about is the test tube clamp. Looks something like this. It does exactly what it says it's going to do, is it holds a test tube, it clamps the test tube together. So when you're heating a test tube, you can hold the test tube with your hand and have a little bit of degree of control of what the test tube does. So if I'm heating it, I would definitely not point the mouth of the test tube at my face because it'll become a cannon. That sounds like a terrible idea. And I would definitely not point the test tube away from me across the lab table because it'll become a cannon, and that sounds like a terrible idea. So if this was my lab station right here, I would maybe point it this way, like toward the window, or this way toward the wall where there's going to be nobody. Okay? So in the event that it does become a cannon and something comes out of it, it won't go into somebody's face. Okay? The last thing that we're going to talk about today is something called the metal tongs. These are good for picking up hot things that have been heated. So if by chance I had a beaker that was really, really hot and I wanted to pick it up, this would be a terrible idea for it. But if I had an Erlenmeyer flask that I wanted to pick up, because of these grooves here or these bends, I could do this. Okay. It also is bent down this way, so I can pick up tiny things like, say, a piece of filter paper. Okay. And we'll talk more about when and how to use these as the time arises. Now, That's basically every piece of lab equipment you will find in your lab drawer. Do you have any questions for me? Okay. This is your homework packet. There is a homework assignment in there. It is a two-sider. It is this side and this side. This side and this side. Okay? You have the majority of the rest of the hour to work on it, and I bet you can't finish it before the end of the hour. Question.
What's the last one?
It's blank on purpose. Okay? So here's the deal. I bet you can't finish that worksheet before the end of the hour. I just bet you can't do it. I mean, out of spite, sure. I don't know, but like, I bet you can't.